Hey everyone, making this video talk about some experiences that I've had on how to make the best possible data science models, how to make your models better, that can mean a lot of different things. I'm speaking from my experience, not just 9 or so years of doing data science research experience working, but also I've had the experience of being in computer science classes and also as a TA of experience to computer science classes over about 100 students. And so over this time, I've been able to look at a lot of different performance-based homeworks and really identify, really brilliant programmers and how they're able to create the best possible data science models in the class. Or everybody really is brilliant, but some individuals can just do a lot of work and they understand the concepts, but they can make just certain errors that make their models just not nearly as good as they could be. So hopefully talk about some of that and maybe prevent some of the errors from happening to you, and also learn from my own personal errors as well. And so I think when you talk about making the best possible models, you really want to start out with like what is the input, and so what that kind of means is like what are you starting with really, and you really want to be realistic. What's your goal? What is this for? Is this a homework thing for a class, a homework assignment for class? You have 2 weeks to do it. Is this a research project that you have a year to do it? Is this a PhD dissertation? Do you want to make a company and do you want this to last forever? Do you want this, this is really important to think about, because you could sit here and try to keep making a model better. You could probably succeed at keep making your model better, but you want to really identify what the end goal is and how to get there. So that way, when you are at the experience right now where you're designing and training the model, you can get there and really have an idea of what it's like going to be like to get there. So again, this is things like your goal. What kind of resources do you have? Do you have a GPU or do you need to rent that out? What's your previous experience? Have you worked with this data set before? Do you have any scripts that you could use or any ideas, or are you starting fresh? And these things will all kind of go into your design and how are you actually going to tackle this? And so the next kind of part of that is, after you have everything else, really the key thing is the data that you have, because will be really where everything ties in together. So you want to think about what you're trying to do as making the best data science model. You're trying to say, okay, given this data and given my constraints. So for example, if you had this for like a homework class or something, right? You have to follow the directions in the homework. You can't use certain models, or you can only use certain data, or maybe you can. But basically, you want to identify, okay, given where I am, given this data, what is the structure of this data? What's the sample size, dimensionality? So these things, when you think about sample size and dimensionality, how many features it has, these will directly play into the kind of model, and it should be able to be a pretty good idea. If you have a lot of data, you can probably think about doing something with more parameters. If you don't, you probably need to constrain yourself, or you need to identify pre-trained models or other resources that will help you take advantage of that amount of data. But this will really shape how to best create the best model, because I've even thought about doing videos about this model is better than this model, or model tier lists, and those would be kind of funny and kind of cool, but really you won't know until you look at their data. Sometimes you can just do something like a linear regression, or like SVM, a random forest, something that's not a huge deep neural network, and it'll just perform way better. And sometimes obviously you need to throw something that is not one of those ones I just mentioned. So it's really just a matter of identifying what your data is, and your data is a really big part of that. And that's also kind of keeping in mind what your experience is. If you have something, if you've already tried something on some similar data, definitely try it again, because it should be a lot less work once you've done it once to kind of work with that. And if you haven't really had that much experience, let's say you're trying a new project in a new field, it's really important here to take a look at how other papers or how other groups or how people actually handle this data. Because as much as I want to think that I'm super smart and I can create these new algorithms that will look at any kind of data, it's a hell of a lot easier just to look at what other people are doing, just to see what other people are doing, and learn from them, because chances are there's a lot of people that have looked at very similar data. And so if you can identify how people look at similar data, if you don't know, or if you do know, obviously be able to pull and kind of see where your data is different. But it spends a lot of time. I think this is really important because you don't want to be in the position where you kind of put in a lot of work and you kind of design an experiment, you just realize that it's not realistic, or the data is not good, or you're not going to be able to get the results that you kind of want, or whatever reason, for whatever reason. So it's really important here, if you do a lot of good work in really designing your architecture, and that goes for even if you're just doing a homework assignment, or if you're doing like a PhD dissertation or creating a company or something like that with this model, you really want to be sure to be able to understand where that will fit in, how you're able to actually fit that into your timeline. And so finally, I think you really want to think about with your input, this is sort of related to your data, but you want to find any additional data or resources, because I've done a lot of work on my PhD dissertation, and pretty much demonstrated that, like, if you can find some similar data set, or if you can figure out, like, models are very intelligent, so if you can figure out some way to give it more data, essentially even something similar, or pre-train it based on the weights of something else, or identify somebody else who has done some work in this domain, you want to improve on it, that will honestly really give you better results a lot of the time. So if your data is like anything close to your original goal. So and really try to think about this. Let's, like, one example would be, I did some work looking at different Yelp reviews, Amazon reviews, and like IMDb reviews. And if you make classifiers that really learn from all of these reviews, especially if you have a small amount of data, you're able to actually make better classifiers than maybe just training on each one of these alone. For identifying, what is a good review or a bad review, even though a product or a movie or whatever could be way different. And so that's kind of really thinking about the inputs and thinking about what you have. And so the other part of that is really thinking about what are the outputs. And so for really what you want to think about when you think about just designing an algorithm, which is, again, a little different than actually like a homework task or a competition, you want to think about what is actually useful, why do we actually care. And so when you think about, like, a lot of things, like, you want to make something, I think a good example is, like, you can make an algorithm that will predict whether or not a patient will respond to a given drug, but that won't be as useful as one maybe saying, if you can identify what the patient's outcomes based on them taking a drug would be. Basically, like, the closer you can get to that end goal, that patient outcomes, and finance, you're following the cash, you're following the money, right? On your homework score, on your competition, you're just looking for a score on usually some test set or some other, you're looking for a tangible object. And so on these, sort of think about whatever you're really looking at, and think about what's really important. And from there, that's how you're going to be able to define it. Because there's also a lot of times you can do things like get a very accurate model. Notice that this isn't like how to improve your accuracy, right? Like, this is get the best data science model. If you get 100% accurate, something that nobody cares about, like, it's not useful at all. It's not a good model. And so it seems kind of obvious to think about, what are the inputs, what are the outputs, right? But if you can really think about these things and really understand what you want out of these, then the middle part gets a lot easier. If you're kind of looking for not just one given task, but you want to make some generalized model, some performance on some benchmarks might be helpful. And so now I'll talk about what are the things that you can actually do while training these models. Let's say you decided the input and the output, and you want to figure out how to improve it. And this is where I see a lot of the students go wrong, because actually when you think about a homework assignment, it's pretty straightforward. Right? You're given what to do, right? You're given pretty much the inputs and the outputs. You don't have to think too hard on that. But what you do have to think about usually is kind of how are you actually going to get there? What's the actual training out process? And the number one thing that even brilliant students that understand the material great, that will put in the effort, that even on any other homework assignment, 9 10s out of 10, they would still get a great grade. But sometimes they essentially overfit, because you can see that they put in all this effort and they spend a lot of time on that. And that is really the key. They spent so much time tuning their model to get the best validation set, to push for that extra 0.1 accuracy, that when they try it to a different data set that's actually not the same distribution as the validation set, or when they submit it to this external evaluation, they actually try to do it, they find out that it's way overfit. And so it's really important here. It's hard because it's really kind of a difficult thing to do. You want to tune your model, you want to try your model, you want to try a couple things, but you really want to be aware of doing it too much. Like, do not do it too much. And I know this is especially hard for a lot of students, because I know that the students will talk to each other. They'll say, oh, I got 85% on this accuracy, or I got 86%, and somebody else is getting 83. We'll just keep on trying, even though the actual test score will be 80% or 82%, and they would have actually gotten the best score, but they'll keep on trying until they just happen to have something that worked on their test set, on their validation set. But then when they actually turn it in to the unlabeled data set, they end up way overfitting. So just be really careful, especially if you're doing this for a homework assignment. Things you can do to prevent this is you can tune more if you have a stupider model. So if your model has less parameters, you don't have to worry about this as much. So that also goes into the kind of input and the output sort of thing. The other thing that I think really helps a lot of students is anytime that they're able to get any other kind of resource. Like I kind of already mentioned this, but things like pre-trained word embeddings, things like pre-trained weights on other models, things like similar data, things like data augmentation sort of, or just like taking weights. Basically, if you can take advantage of any other kind of data, because the hardest thing to do is really just given a small data set without any other resources, kind of train a model. So anytime you want to do that, you definitely want to try to see if you can. A lot of times on homework assignments or competitions, you might not be able to, but definitely if you're doing this in like a research setting, definitely look into other similar data. It will really definitely it helped me out immensely, and I see it like a lot of students that will use pre-trained word embeddings versus trying to train their own or something like that ends up doing a lot better. So any kind of way that you can adjust your model to take into account some other resource, definitely try it and see if it works out better. But then again, also be aware, don't try it too much or you also get into the overfitting problem. Next thing is anytime you can get data, this is kind of, I'm not gonna spend too much time. Anytime you can get data usually will be better. If you think your data is at all better, even like 51% of the time accurate, usually it's better to include it because the idea is the noise, it'll learn past the noise to see what your true signals are. And so finally, I think a lot of people may not do this. So this is kind of goes into the concept of overfitting. But when you do train a model, it's really important, especially every time you are going to tune your model, really try to look at the errors, try to understand the errors. And so what I mean by that, like for one example, we had students classify whether or not segments of code were coming from different like subreddits based on if they were like Python code, R code, C++ code. If you're able to actually, if you know what these codes look like, you should be able to kind of go through your algorithm and be able to see, okay, well, this is sort of a Python code, but my code is classifying it as C++. Or you could just say something, it's classifying everything as one class, and that's kind of helpful to know too. You're going to want to adjust your weights there. But this kind of goes into really knowing the domain and kind of knowing what's really important behind what you're doing. And so this can kind of be just anytime you can kind of look at a model and be like, oh, like if you're looking at histology images, oh, if it doesn't really detect it well in these areas of the body, or if you're looking at finance and it doesn't work well this model doesn't work well in these sectors, and really trying to experiment and try to understand why that, so that every time you try to run a model and you try to improve it, and you don't do this again too often because you don't want to you would avoid overfitting, but you try something, you really try to understand where your model went wrong without trying too many times, right? Just try to really, every single time you try, take that as like a really submission, try to learn as much as you can from that iteration, tune your model however you think will be better, then try to go through everything again, and that will generally help you. Again, just avoid doing it too much. And so finally, I think this is actually kind of important. I will kind of talk about this, but not too much. Really, you're probably going to want to show this model to other people, or it'll be implemented with other people. And just some things to keep in mind. There's really who is the audience. It's really important to be, you don't want to just show everything. A lot of people honestly don't care how you trained your model. They don't care about all of that stuff. Essentially, just be mindful of who you're talking to. Next, I think it's really important to be objective and state your assumptions of your model. A lot of times we like to think of this as like a really super good model, but if you just state your assumptions honestly, you can find out how to actually improve that, and maybe learn from that as well. And then finally, I think whenever you think about sort of data science models, this goes into design, everything. Think about it in the language and the context of what you're doing. Like you want to speak to the kind of language that is normally used with this sort of data. You want to use that language in this domain in order to show that your model is superior. And so finally, I'll just talk about like AlphaFold 2. This was a really successful data science project, and some things that they did. Their objective was pretty straightforward in their input and output. They were just working on a competition. Basically, they were just trying to predict protein structure, whether or not how far each of these individuals, like what each of the residues they predicted, basically the distance. And so they were just trying to predict the shape, and the distance from the ideal shape was the score. But what they really able to do, the kind of key of why it kind of hit the news with pretty heavily, was because they used this other publicly available data sets. Basically, they're using not just the information of them given that they were given in the competition, not just one protein sequence, but they're using the database of all the other related protein sequences related to that one sequence. So they're able to really use that publicly available data in order to improve their models. So I think it's pretty interesting, and thanks for watching.